No. Mathematical radical.
Okay, so you might say, why do we need to study trig identities? Well, let me just show you something. This is in your book, but I went ahead and printed it or put it up here. Did you know that when you dial a phone number on your iPhone, how does the smartphone know which key you've pressed? Dual tone multi-frequency, DTMF, also known as touch-tone dialing, was developed by Bell Labs in the 1960s. Touch-tone system also introduced a standardized keypad layout. After testing 8 different layouts, Bell Labs eventually chose the one familiar to us today, with 1 in the upper left and 0 at the bottom between the star and the pound keys. The keypad is laid out in a 4x3 matrix, with each row representing a low frequency and each column representing a high frequency. When you press the number 8, for example, the phone sends a sinusoidal tone that combines a low frequency tone of 852 Hz and a high frequency tone of 1336 Hz. The result can be found using sum to product trig identities. So actually using your smartphone, that you are able to use your smartphone because of trigonometry.
Boom.
Boom.
Yeah.
All right.
So is that the sound you hear? When you put the...
I don't know, maybe. Maybe it's an internal sound. I don't know, because you can make it silent. But yeah, so they use trigonometry to help them develop the keypad and to know what number you are pushing on the keypad. So that's pretty cool. All right, so let's get back. Okay, so we have 3 sets of trig identities we're going to look at today. We're going to look at reciprocal, quotient, and then Pythagorean. So here's our first reciprocal identities. We call them that because these 2 functions are reciprocals of each other. So cosecant and sine are reciprocal functions, trig functions, so we can write these 2 identities based on that. So cosecant and sine are reciprocal of each other. We know that we get the cosecant by taking the 1 over the sine, or the reciprocal of sine. We can get the sine by taking the reciprocal of cosecant. So those are reciprocal functions. And then, of course, secant and cosine are reciprocal of each other, and cotangent and tangent are the last pair of reciprocal identities. Kind of review. We've done some of these before, but we're going to use the identities. The identities allow us to simplify this or calculate this. So if we know that the sine of theta is radical 2 over 2, and we want to find the cosecant, then we could go up to this identity, and we know that cosecant's the reciprocal of sine. So 1 over means just basically to flip that. So the cosecant will be 2 over radical 2, and we would want to rationalize that denominator. So we get 2 radical 2 over 2, which those just cancel. And our final answer is just the square root of 2. Okay, so in this case, we've got a variable that represents the value of the cotangent of theta, and we want to know the tangent of theta in relation to that. So tangent of theta is 1 over the cotangent of theta. So we would just rewrite this as 1 over a, because the cotangent of theta is a, and that's it. We're done. That's the value of the tangent of theta. Let's do one more, I think. Yep. We know the secant. We want to find the cosine. So we know we're trying to find the cosine. So cosine is right here. It's going to be 1 over the secant. And we know the secant is -3. So our cosine will be 1 over -3, which is the same as -1/3. There we go. The next things that we have 3 types of identities, or 3 divisions, 3 sections. We did the reciprocal. Now we're going to look at the 2 quotient identities, and those are tangent and cotangent. And so tangent is figured sine theta over cosine theta, And because cotangents, it's reciprocal, then we would just flip that and it would be cosine over sine of theta. Okay, so first thing we're going to do is find tangent of theta. And our formula tells us that we take the sine over the cosine. So sine is 3/5. Cosine is a negative 4/5. And you could do that on your calculator, or you could flip and multiply. So that's going to give you, we're going to take 3/5 times 5 over negative 4. 5's cancel, and we get 3 over negative 4, or negative 3/4 for the tangent. Cotangent is just going to be the reciprocal of that, right? So we don't need to use this formula. We can just flip what we got for tangent to get cotangent. So cotangent would be negative 4/3. There we go. Okay, so we've done the reciprocal, we've done the quotient, then the last set of identities are going to be Pythagorean. But before we get to that, we need to talk about how we write things a little bit differently when we're working with trig functions. So if we want to square the sine of theta, that's this is the operation we want to do. We want to square the sine of theta. But the notation that we make for that is we put the squared after the sine. And the reason why we do that is because if we didn't, then often people would write probably, okay, they would forget about the parentheses, and I want to square the sine of theta, but then that actually reads as squaring theta and then taking the sine of it. So which is completely different from this. So I think to eliminate that confusion, it was decided that if we want to square the sine function, we're going to write it like this, and we would say it's sine squared theta. So this would be said, we would say that sine squared theta, which means you're going to square the sine of theta. So if, let's say for example, sine of theta was radical 3/2, and we wanted to find the sine squared of theta, we would square the square root of 3/2 and get 3/4. If we wanted to cube a trig function, so for example, we want to cube the cosine of theta, again we would write it this way, and we would just say cosine cubed of theta. And an example of that would be listed here. We know the cosine is a negative 1/2. If we want to cube the cosine, then we would cube its value of negative 1/2 and get a negative 1/8. And we have 3 Pythagorean identities. I'll just let you write those down and we'll discuss them. So the first one, you'll use it on ACT tests. You're going to see this at some point. Sine squared theta plus cosine squared theta equals 1. You'll see that identity somewhere on the test. And then, so that's the most common used Pythagorean identity. And then the other 2 follow from that. So if we have the sine of theta, we could use this Pythagorean identity and find the cosine. If we knew the tangent, we could find the secant. If we knew the cosecant, we could find the cotangent. So these allow us to find different values, different from what the reciprocal identities and the quotient identities will allow us to do. So let's do a couple of problems where we're going to use the Pythagorean identities. Here's the first one. Okay, so the first thing we're going to do is we're trying to find the cosine and the tangent, and we know that the sine of theta is 4/5. So my first step is going to be to find the cosine, and I can use this identity, sine squared theta plus cosine squared theta equals 1, to do that. So I'm going to write that sine squared theta plus cosine squared theta equals 1. And where I see sine theta, I'm going to put 4/5. But I'm going to square it because it's sine squared. Now I can simplify 4/5 squared is going to be 16 over 25. And plus my cosine squared theta equals 1. And I want to isolate the cosine function, so that means I'm going to subtract 16/25 from both sides. So on the left, I have cosine squared of theta equals 1 minus 16/25, and that's going to be 9/25. So if my first answer needs to be cosine of theta, not cosine squared. So how do we undo a square? Square root. So we can still do this, square root, so that gives us cosine of theta. And when we square root in an equation, we can get both the positive and the negative values, so that gives us a positive or a negative 3/5. But we have to decide on which one it is, whether it's positive or negative, and this helps us do that. Remember when we have in our 4 quadrants, all students take calc, that little thing to help us remember what functions are positive. So in the first quadrant, all 6 trig functions are positive. In the second quadrant, sine and its reciprocal are positive. In the third, tangent and its reciprocal are positive, and in the fourth, cosine and its reciprocal. So in the second quadrant, that's where this angle terminal side lies. Is the cosine positive? No. So our answer is going to be negative 3/5. So we're just going to erase that positive, or I'm just going to rewrite our answer as cosine theta is negative 3/5, right? Okay, so there's our first answer, and then the second answer is we're going to find the tangent, and we use the reciprocal, not the reciprocal, but the quotient. Tangent's sine over cosine. So the tangent of theta is going to be sine, which is, they gave us as 4/5. We did this one already, I think, or close to this. And when you simplify, you flip and multiply, and that gives you a negative 4/3. So there's your 2 answers. So in this problem, we're given the cotangent, and we're trying to find the cosecant. So I would use the identity that involves both of those, the Pythagorean identity, and that is 1 plus cotangent squared theta equals cosecant squared theta. And I know what the cotangent is, so I'm just going to plug that value in for cotangent. So that gives me 1 plus negative 3, but I'm going to square that, equals cosecant squared. And 1 plus a negative 3 squared. A negative 3 squared is 9, plus 1 would be 10. And we want just the cosecant, not the squared, cosecant squared. So to undo that, we will square root both sides. Radical 10 doesn't break down. We just need to decide whether it's positive or negative based on the quadrant that our angle terminal side lies in. So all students, we're in quadrant 2. Sine and its reciprocal will be positive. So it's cosecant's the reciprocal of sine, right? So our answer will be positive 10, square root of 10. Okay, we're trying to find the sine and the cotangent, and we know the cosine. So I know there's an identity that involves sine and cosine. There's not one that involves cotangent and cosine. So I'm going to go with sine and cosine, because once I know both of those, I can find the cotangent, right? Okay, so the identity that I'm going to use is the most common one, sine squared theta